All right, hi everybody. We're going to do another integral test problem. And the problem that we're going to do is to determine the convergence of this series right here. Now, this is a very famous series. This is called the harmonic series. Everybody should already know if you're at the integral test and you don't know whether this converges or not, you would probably you need to review your earlier sections. This diverges. Some sort of argument like you've got 1 plus a half plus a third plus a fourth plus a fifth. You write out all these terms. You've got 1 plus a half plus, and then you say, hey, these are this is greater than 1/4 plus a fourth plus an eighth plus an eighth plus an eighth. And so basically the harmonic series is greater than 1 plus a half plus a half plus a half forever, which is infinity. So to say it's greater than infinity means it goes to infinity. For us, we're going to use this problem to work on the integral test. The integral test says, hey, if you need to kind of know if something converges, this will converge. So if the integral of it converges, then the series converges. So let's look at that. What about the integral of this? So remember that you, instead of the n, you put the x, something to talk about there. But for now, we're trying to get the basics here. So does the integral from 1 to infinity of 1 over x converge? Meaning, is it finite? Well, first of all, we need to convert this, this limit of integration here, this infinity, we'll convert that to a b and let b go to infinity on the outside. Let b limit to infinity on the outside so that well that's the general procedure for dealing with an infinity on the limit bound. All right, so here we have the integral of this one. Now, just so that we're clear, a lot of students think, hey, this is x to the -1. What I'll do is I'll add 1 to that, which gets me 0, but then I need to put that under there. Well, you can't put a 1 under there, unfortunately. So what you have to remember here is that this is the natural log of absolute value of x that you need to evaluate there. The integral of 1 over x is absolute value of natural log of absolute value of x, not just natural log x. All right, so where does this go? All right, so you got your limit. Let's write it like this. L saves a couple strokes of the pen. All right, so we have absolute value of b minus natural log of 1, absolute value of 1. Now, b and 1 are both positive. We know b is positive because b is after 1 right there. It's a positive number. So what are we looking at here? We're looking at the limit of the natural log of b, and natural log of 1 is 0. Remember that that's actually, this thing comes up from the depths and it grows very slow, but where it crosses the x-axis is 1. So the natural log of 1 is 0. So this is 0. Now, the limit as b goes to 0 of natural log, we can look at this graph yet again and say, hey, if b is walking all the way to infinity, what's the height going on? What is the height happen? What is the height of this natural log function? Well, surprisingly, that does go higher and higher and higher and higher, and it never stops going higher. And so this limit is actually positive infinity. So, so this integral is not finite. Now, how does that sit with the problem? Is everything going to be okay with this problem? Well, the integral test says if this converges, then blah, 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 blah. Well, it didn't converge. So the integral test has a lot to say. If it would have converged, it would have had a lot to say. And this is what I mean by a lot to say over here. It says if this, then, and then it has a lot to say, right? It has all this conclusions and stuff. Well, the integral didn't converge. So the integral test says nothing here. So maybe we should write that. The, let's say the IT says nothing here. You would need to use a different test to determine the convergence of this series. So this was an inconclusive attempt to apply the integral test.